Hello, let's get started. I'm George Barnett. I'm host for the next hour and about 12 minutes. I have the honor of introducing our keynote speaker, Matthew Jackson. Matthew is the William D. Eberle Professor of Economics at Stanford University. Matthew received his undergraduate degree from Princeton and his doctorate from Stanford in economics. Professor Jackson has previously taught at Northwestern and Caltech. He has received numerous honors, including the Guggenheim Fellowship, the Eberle Prize for Senior Economists, election as a Fellow of the American Academy of Arts and Sciences, and an honorary degree at pardon my French, Aix-Marseille University. Professor Jackson has served as editor of Econometrica, Games and Economic Behavior, as well as being associate editor of many other journals. He has published over 120 articles, edited 7 volumes, and has authored Social and Economic Networks, which I personally use as a reference and cite extensively. What greater praise could I give to our keynote speaker? The title of Professor Jackson's talk is Information and Gossip in Networks and Interactions with Microfinance. Matthew?
So thank you to George for that kind introduction, and I want to thank the Institute for this opportunity to be part of this growing interface between the social sciences and the other sciences. And I think it's a very interesting area, we've seen an amazing menu of talks today, which bring together ideas crisscrossing, and it's actually nice to follow the previous panel because some of the ideas that I'll be talking about were discussed there. And this is just a quote. Here's Don Corleone, so we have a fictional organized crime member instead of Al Capone. But one thing we'll be talking about is exchange of favors and how that interfaces with other types of relationships and information. And so this is I'll be talking largely about a joint project which has been going on for about a decade now with Abhijit Banerjee, Arun Chandrasekhar, and Esther Duflo. We've been collecting data in rural India, and we've been studying how networks affect information diffusion. And the part that's going to relate to favors is how the interaction with markets actually changes the shape of these networks and how that changes information flows within the societies. So just in terms of a starting point, it's obvious that networks impact information flows, they affect diffusion, they affect what you also know about other people's position in a network. So whether or not you think somebody's influential in your community, who you would go to find advice, who do you think would be a good source of information. So not only who's good at spreading information, but who people seek out or who might be good for spreading things. So that's something that we're going to be looking at in detail. And those networks are also shaped by interactions with other kinds of relationships, and that's something I'll talk about. So in terms of the basic issues that we'll start with, one is which measures are capturing people's influence in a network. So if we want to find the right people to diffuse information in a society, say about a new project, a new program, we want to get news out, who's good for doing that, and how do we measure that? So I'll talk a little bit about developing a very process-based measure for doing this and comparing it to sort of the off-the-shelf centrality and influence measures that are out there in the standard literature. And this is a little bit of where we started with this project. And the second piece that's going to relate to the gossip is how are people within a network aware of the people around them and their positions? So you think people are important. Are they really important? Could you tell us, for instance, who at UC Davis would be the critical people for getting information out? And would you be accurate in doing that? And if so, how might you come to that information? So we're not looking, we'll put networks up on the screen here, you'll be able to see them, But in your day-to-day lives, you don't see those networks. You have perceptions that you're getting from information that's hitting you. And how on earth do you have any idea of who's important beyond your immediate sphere? So that's one of the central questions that we'll be talking about. The second part of this relates to the multiplexing or multilayering that we were talking about a bit. So it was a really nice setup here today. So people interact on many dimensions. They share favors, they share information, risk, behaviors. There's all kinds of externalities between these. And there's complementarities between these. So we see them layered on top of each other for different reasons. And I'll talk about that. So, the fact that we borrow in these villages, that we borrow and lend kerosene and rice together, makes it easier for us to borrow and lend money together, and vice versa. And that's also going to affect who we seek advice from and other kinds of things. So these things are going to be interrelated, and that means that it's possible that, if we start introducing, say, microfinance into these villages, that can end up destroying lending relationships, which end up affecting the other parts of the network. So people are going to have less advice networking going on as a result of exposure to microfinance. So we'll look at that in some detail. So just in terms of an outline, what I'm going to do is there's basically three main pieces of what we're going to go through. First of all, how do we measure centrality when we're thinking about information spreading? In this case, diffusion of microfinance, and I'll explain exactly what we were looking at in a moment. And then the second part, how do people come to know something about their network, the networks around them? And often we think of gossip as a negative thing, but gossip is going to be very powerful at informing us about who's important in the network. So actually gossip is going to play a good role of helping us to understand what's going on in the network at a greater distance from us. And then the last part will come to this multiplexing. Luckily, in terms of the data collection here, we have a situation where we have a nice, in some sense, natural experiment where we'll have a whole series of villages that were affected by microfinance and some that weren't, and now we can see how these networks are changing in result to that. So the first parts are going to be looking at these networks and trying to figure out how the information's working, and then the second part will be how were those networks actually affected by the fact that the bank came in and started offering formal loans and destroying some of the social fabric that had been there, and what are the implications of that as we go forward. Okay, so let's start with how to measure centrality, and this is the first part of the work that we did on this in the diffusion of microfinance. And just in terms of empirical background, what we did was went in starting in about 2006 in rural Karnataka together with a microfinance organization that was offering loans. And what they were interested in doing was understanding why they were getting such dramatically different outcomes in different settings. So they would go into village by village. More or less, they were targeting villages that were very similar from their perspective. And yet, in one village, they would get a widespread diffusion, and in another village, they would get next to nothing. So in our data, you'll get 7% in the worst village in terms of participation, and about 44% in other villages. So there's a wide variety of how successful this is, and they were trying to understand why. And they were relying on word of mouth to get the information out. And so what we're going to do is we went in, mapped out the networks, and tried to understand, why were they being successful in some places and failing in others. And that's important from their perspective. It's hard to run one of these loan programs unless you have enough participation. There's a lot of fixed costs involved. And if you're not getting it out enough, you're going to stop the loan programs, and then these villages wouldn't have the microcredit that they might need. Okay, so word of mouth was essential in these villages, and that's mainly because these are fairly rural and poor villages. Per capita income in these villages is about $1 a day. So their word of mouth was the essential way to get information out, and we'll look at that in some detail. Okay, so there were 75 villages, originally 77 and then down to 75 villages in Karnataka, relatively isolated from microfinance. And the bank entered 43 of them and offered microfinance. Luckily for us, they did not enter the other 32. So 2009 came, there was a financial crisis. They stopped entering villages. For us, that gives a nice control because we have 43 villages that they entered and 32 they didn't. So that'll be a nice comparison afterwards. We tracked microfinance participation over time, and we surveyed the networks before and after the microfinance. Okay, so here we are, Karnataka. The villages are all within about a 100-kilometer band around Bangalore. So they're relatively small villages, about 1,000 people each, 200 households roughly. Here's a picture of one. They're agricultural, mainly agricultural, some day laboring. So they grow finger millet, some sericulture, so silkworm production, some small textile production, other kinds of things. Here's another picture. This is actually a picture I took of a village slightly to the north for other reasons. But you see, one thing we'll keep track of is how wealthy households are. We can track that by looking at things like roof types. You can see here, actually, the air quality in the winter is not so good there. They tend to burn cow pies for heat. We'll talk a little more about exchanges of kerosene and other kinds of things. So what we did is we went in, we collected the network data, and in particular, we collected 13 different types of relationships. And we did that for a couple of reasons. One is if you go, just for pure survey techniques, if you go in and you just ask people, name your friends, it's actually difficult to remember all your friends. And so instead of just asking who your friends are, it's easier to ask them very specific questions. So, who have you borrowed money from, or who have you borrowed kerosene and rice from? Who do you go to? So there's a series of questions. Asking pointed questions is a little easier in terms of recall. The other is that we really wanted to get multi-layer information. So that'll allow us to study interactions between these networks. So this is one of the villages. If you had to borrow 50 rupees for a day, who would you go to? So in this case, each one of these small clusters is a household, and there's a directed arrow if one of the people in one household named somebody in the other household. Okay. And what we're going to do is we're going to treat these things at the household level because loans were restricted to one. This is a Grameen-style lending program, so it's only to women between 18 and 57 years old, limited to one per household, and so we'll treat the households as the units. So you end up with a network of borrowing. Here's who do you go to temple with, fairly sparse in this village. Who do you ask for important advice? Who comes to you to borrow kerosene or rice? Who would you go to in an emergency for medical help? So we have a whole series of different networks, and we're going to layer them on top of each other. So for the purposes of the first part of the talk, what I'm going to do is I'm going to treat these as one large network, and we'll treat two households as connected if they said yes on any of these, because we're mainly interested in whether they talk to each other and whether information might flow from one to another. In the second part of the talk, then I'll start taking these layers apart, peeling back the onion, and then seeing how they connect to each other and how they're influenced by each other. Okay. There's also a lot of demographic information. You can begin to paint these by caste, for instance. So here, what I did, this is Village 26, the kerosene and rice network. And now I've just agglomerated things to the household level. And there's a link between two households if they're borrowing or lending kerosene and rice together. Here, blue nodes are scheduled castes and scheduled tribes. So this is the set of castes that are recognized by the Indian government for affirmative action. The red ones are the otherwise backward castes and general or forward castes. And those are the ones that are relatively advantaged. And here, you begin to see that there is clustering in the data. So you can see that the probability of a link or the frequency of links across red and blue is 0.6%. The frequency of links within is 9%. So there's a strong difference, and that's not surprising if you know any of the caste history in India. But you can also see that there's 53 subcastes in these villages. Here you can see that there's also a dichotomy between this part of the blues and this part of the blues. So there's further modularity, and that'll affect things like diffusion. And so there's a lot of information within the data that we'll control for, and I'll talk about as we go along. Beyond this, we have a lot of other information. Microfinance participation by individual and time. Age, gender, religion, profession, education, wealth variables, self-help group participation, voting. And actually, these data are available on my website. So if people are interested in this, you can have access to these data. So there's a lot here. Okay, so let's start with the information passing. And the main thing that we were investigating for the first question was whether or not hitting the right nodes was important. And was it explaining why the bank was successful in some villages and not in others? And so in particular, what the bank instructed its loan people to do was to go into a village and look for the leaders in the village. And in particular, they were targeting people that they thought would be well connected. And so they were targeting shopkeepers, self-help group leaders, and teachers. They thought these were people that would interact a lot. And so they would identify these individuals, and then they would tell them, look, we're going to be back in a couple of weeks with a loan program. Tell your friends, get the word out. And then they came back in 2 weeks, and people would show up. And then people that would show up, they could say, okay, you can tell your friends too, and so forth. And so the idea was that this would diffuse by word of mouth. So, do the first injection points matter? And this is a question that goes back to Simmel, or the idea that key individuals are important in processes of diffusion is something that's been long studied. And what we can do is take a look at some of the different measures that are there and then see how they perform. And so first, the basic centrality measures in networks, the most obvious one is just count how many friends you have, right? So you count your number of connections, you look at the degree of a node, the number of connections it has, and nodes with higher degrees should be better at decentralizing information. That would be one hypothesis we might have, right? So here we have, one with 7, one with 6. These would be the most central nodes in these two subnetworks. Okay, what's wrong with degree centrality? Well, degree centrality doesn't capture much beyond the original neighborhood, and so this 2 being connected to a 7 and 6 is in a much better position than this 2, which is connected to 2 2s. There's also a sense in which this node is closer to a lot of the other nodes than the other one. So there's a lot of things that is not captured in this very basic, just counting popularity contest sort of variables. So the idea that it is usually used to capture this idea that it's not only how many friends I have, but how important those friends are, is what's known as eigenvector centrality. And so in eigenvector centrality, what network scientists do is you say, okay, the centrality of some node I or some family of villagers in this case is not only proportional to how many friends they have, but actually to the centrality of those friends, right? So I want to say you're more important if you have more important friends, and we'll weight your friendships by the importance of those friends. Okay. Well, this gives us a system now that is self-referential, right? So my centrality is dependent on my friend's centrality and so forth. Luckily, the eigenvectors have a nice, they work out well. So here we have a system of equations and a system of unknowns, and as long as the matrix isn't too peculiar, you end up with a nice solution, and that's the eigenvector centrality measure. So this is a well-defined system. It has a non-negative solution. And in particular, if you go back to this network we had before, now you can begin to see that this node looks a lot more central than this other node, because now we've adjusted for the fact that it's better connected than the others. And in fact, the highest centrality node is not the one with the highest degree, but it's one that is much more central in a well-defined sense. So another hypothesis we might have is instead of just looking for degree, they should be looking for people with higher eigenvector centrality in order to diffuse information. Okay? So what the bank did then was, they informed these individuals, news spread out, and luckily for us, the teachers in some villages tended to be highly central according to these measures, and in other villages didn't. And so we can use that variation to see whether or not when they hit the ones that had high, say, eigenvector centrality, did that diffuse information better than in villages where they hit people that had low eigenvector centrality. So the first test would just be, does this predict how well they did in some of the villages? Okay, so we have these two hypotheses. Let's look at degree, let's look at eigenvector centrality. So the first plot is one where here we have the average degree of these leaders that they talked to. So when they went into the village, we can look at the households, count up what was the average degree of those households, and see how well they did. So each one of these points is a village. one of the 70, so here, one of the 43 villages. And so here we have a point where they got about 8% participation rate, and the average degree of the households was about 22. So each of these households had about 22 friends. The one that's up here is also at about degree 22, and it's 44%. So obviously this isn't explaining it. Degree isn't doing much. And in fact, if you fit a line through here, you get a negative relationship and insignificant. So that's not doing a whole lot. If we look at eigenvector centrality, now you get a positive relationship and a significant relationship. So it's explaining more of what's going on in the data. And it's giving us, picking up the fact that if you really want to think about diffusion, it's not just a one-step process, but it's a process which is going to depend on how well my friends are also at spreading information. And so that fact that it's iterating is picking up a lot more than the degree was, and it's a better predictor of the eventual success of these programs. Okay, so that's sort of lesson number one that we have. Then what did we do? Neither of these measures is actually explicitly modeled based on diffusion. So instead, let's just take a simple epidemiological process like the one that Raisa was talking about earlier, where instead of just taking an off-the-shelf measure, let's model that process. And so what we're going to do is model this as a diffusion process, and we're just going to take a really simple epidemiological model and adapt it to a centrality measure. What we're going to do is say, let's look at a given node, and suppose they're the first one that's informed. And let's just suppose that they talk to their neighbors randomly every day. So with some probability, I talk to my neighbors, and then we just do a count. So we'll count how many of my neighbors become informed. And then the next day, I'll randomly bump into people again, I talk, and other people talk, and we'll just let this go out. So we'll have two parameters. One parameter is P, what's the probability that I talk to any given friend in a given time period? And then T is going to be how long we run this process for. So if we run it just one day, all I'm going to do is tell my immediate friends. If we run for 10 days, then it has a chance to reach out 10 steps in the network. And so we'll keep these two parameters as the relevant parameters of this measure. Okay, so here we have the initial node. If we're running this, say, with a probability of half that I talk to any neighbor for 4 periods, first period, I happen to talk to a neighbor. Second period, I talk to somebody else, they talk to some people, and so forth. So you could go through, after 4 periods, this node would have talked to 13. So by simulation, you could say this person's diffusion centrality for this kind of process would be 13 people I'd expect to be informed. We can do the same thing for another node. So it talks to 1, 2, by the end of the 4 period, it's talked to 6. So this node would seem to be half as good at telling people as the first node. So the other node is a better node for diffusing information according to this measure. Now you could simulate this. You can simulate it as many times as you want. You can also do a fairly direct calculation just by counting the walks in the network and then weighting them by this probability. And so there's a formula that you can come up with which characterizes this directly. But what we show in the paper, the first part's very obvious. If communication occurs just once, then this is just going to be proportional to how many neighbors I have, and it's just going to be degree centrality. So this measure on one extreme becomes degree centrality. On the other extreme, if you run t to infinity, then this converges to eigenvector centrality. So you can show that as long as p is large enough, it has to be bigger than 1 over the first eigenvalue of the matrix. But as long as it's non-trivial and the process doesn't completely die out, then what's going to happen is this diffusion process is going to look like diffusion eigenvector centrality in the limit. So the idea is on one extreme, degree centrality is like a really short diffusion process. Eigenvector centrality is like an infinite diffusion process. And most likely, it's somewhere in between. So most people get tired of talking about a subject after a while. And you can imagine that information spreading dies out over time. And that instead, the actual signature in these villages should be somewhere in between. And so we can use diffusion centrality and see if that does better than the other measures at explaining what's going on. So here we can say higher diffusion centrality is going to predict better participation. Now here we have to make choices on how many periods. Now we have this variable t and this probability p. So what we did was we actually worked with T to be the number of trimesters that a village was exposed to microfinance, so we kept just track of the calendar time that the village was exposed. And then the P, we do two ways. What I'll show you is just setting it to 1 over the first eigenvalue, which is a way of tying our hands. But you can fit it to the data, and if you fit it to the data, you'll get even a better fit than what we did. But you should expect diffusion centrality to do better just because it's nesting the other two measures, right? So if you go through, it's going to be positive and significant now in terms of predicting how the diffusion centrality of these groups of leaders was in terms of predicting eventual take-up. And in particular, if you do regressions of the microfinance participation on these different measures, you'll find that the only two centrality measures that are significant are eigenvector and diffusion centrality. And in particular, if you look at the R squared for people that are like statistics, here what you're doing is you end up explaining almost half the variation when you use diffusion centrality. You get about a third of the variation if you're doing eigenvector, and eigenvector is not doing much better than sort of nothing at all in this case. So there seems to be something in terms of this measure of capturing a little bit more. So the idea of here looking at a specific model or specific process of how people are interacting gives us measures of influence that are going to be more predictive of what's going to happen in a particular network. And so this is more a methodological point than anything else, but it seems to work well in understanding what's happening in these villages. Okay. So now let's go to the second part. And the second part was, okay, we've answered one question for the bank, which is, it looks like if you went into villages and found people that have higher eigenvector centrality or diffusion centrality, that would be, improve your take-up rate. So the bank comes back and says, well, how do we do that? How do we identify that? Well, they're not going to do what we did, which is go in and sit in each household for 2 hours interviewing people and asking the full network. At that point, they should just tell them about the loan program, right? So it didn't make much sense for them to go and follow the same procedure we did. So we had a question of, how do you actually discover this information without seeing the network? And here, what we thought is, well, maybe we should just ask the people in the village. So the villagers might be able to tell us who's central. We couldn't go in and ask them who's eigenvector central in your village. So what we did was we went in and we just asked them an operational question of, if we have information that we want to spread in your village, who should we talk to? So that was the basic idea. So we went in and we asked every adult in the villages, who's the best starting point for a diffusion process? And then we want to see whether they're able to actually tell us the people that are highly central in these ways and actually predict that. So we're going to work with households as units again. Here we went into just 33 of the 43 villages, average 196 households per village. And we asked them, if we want to spread information about a new loan product to everyone in your village, to whom do you suggest we speak? So just something directly related to the microfinance question. And the second question we asked them was just to make sure that loans weren't somehow special in their minds. We asked them if we want to spread information to everybody in the village about tickets to a music event, drama, or fair that we'd like to organize, to whom should we speak? So we asked both questions. I'll stick mainly to the loans because the answers to the questions worked out to be mainly very similar across the two questions. So first of all, when they did name people, they tended to focus on a subset of the households. So out of all the names we got, there were only tended to be about 5% of the households named in a typical village. So that means that people were naming the same households over and over. So that's good news for us. That somehow they think that they're answering the same people to this question. And in fact, conditional on being named once, your average number of namings was 9. So once you were named once, you tended to be named a lot of times. So we could ask, now are they naming people who are highly central? And so this is just the nominations per household, and here's the quintile of centrality. So this is, if you're a household that's very central, you're somewhere above 80 percentile in terms of the ranking of centrality in the village. And you can do this either by eigenvector or diffusion centrality. It'll work either way in this case. You get named on average at least once. If you're in the 60th to 80th percentile, you get named about half a time, and then the lower ones get named about 1 in 5 of those households get named. So they are tending to name people who are more central. There's something else going on as well, because they are naming some of the lower households. And you can imagine that they're taking into account things beyond just the network when they're thinking about who's good to spread information. And so, we can look at how well they do in terms of spreading information. But one question is, how might they actually come to know this? And we're going to posit the following hypothesis. So it turns out if David Krackhart has a series of studies from the 1970s and 80s, which asked people, to name which of their friends were actually friends with each other. And if you ask people about their immediate friends, they're reasonably good at knowing who's friends with whom. But if you go out 2 steps, they're slightly better than random. And once you go out 3 steps, they're pretty lousy. So basically, people don't have a good picture of the network beyond their sort of immediate friend patterns. And so we might ask, how on earth are they naming highly central people if they're not really good at answering, what my network looks like? So they can't paint the picture of the network, but somehow they're able to connect the dots in terms of saying, this is somebody who's a good person for getting information out. So what we're going to do is look at gossip. And the idea here is people are going to be receiving information on a regular basis. So imagine that I'm just getting hit by gossip. So Arun moved to Stanford, Matt has a new MOOC, Esther won an award. So these random bits of news are coming out from these nodes. And let's suppose that the news spreads by the same process that we talked about for the diffusion. So it randomly bounces from node to node. And it starts in near the original node, and then it spreads outwards. And what I'm going to do as a listener, so now we're just flipping the process. Before we were asking who's a good broadcaster. Now I'm just sitting here as a listener, and all I'm going to do is count how many times I hear about different people. So I'm not going to do anything sophisticated. I'm just going to sit here and I'm going to say, I've heard 5 pieces of information about Arun, 7 about Esther, 4 about Matt, and so forth. So all I'm doing is just, this is somebody I've heard a lot about. This is somebody I don't hear about very often. And now I'm going to rank people, and I'll say, this person must be central because I hear about them all the time. And this person can't be that important because I don't hear about them much. So that's the mental accounting we're going to do. And here I'm going to assume that every news about each person in the network is coming out with equal probability. What's going to be important is that at least it's not negatively correlated with people's position in the network. It could be positively correlated, that'll help us. If it's negatively correlated, then that'll undo what I'm going to talk about. Okay, so people do this, and now they rank people, and they say, okay, person 8 here is the most central, Esther's the second, and so forth. So they'll give us that ranking. And what you can prove is that, just by doing this, if people are in the village long enough, and news is popping up from different nodes over time, then just by doing this simple accounting, they will end up with the proper ranking. So this is sort of a limit theorem, which says every individual's ranking of others under network gossip will be according to the ranking of diffusion centrality for large enough P and T. So P, again, has to be at least 1 over the first eigenvalue, and there's a finite T after which everybody in a village would have a correct ranking of everyone else in the village just by doing this sort of simple accounting. Okay, so they don't have to be sophisticated, they don't have to be Bayesians, they don't have to do anything other than just count. And the idea here is that that'll teach them who's central according to this process, because the people who are really central are just going to, that information is going to reach them with higher probability. So it's a very intuitive and fairly simple. The math behind the proof is a little more complicated, but the idea is fairly simple. Okay, so gossip then leads to accurate knowledge. With many iterations, everybody's ranking is going to be according to diffusion centrality and in the limit as t goes to infinity eigenvector. For small numbers of iterations, the average network gossip. So if we only talked for a little bit of time, I might not hear about people far away from me very often. So it's going to take a longer time for that information really to spread. So in the short run, you can show it's positively correlated, and in the long run, people will become accurate. Okay, so now we've got our policy question, then how do we identify central people without actually mapping out the networks? And then we're asking people, and if we use this information that they're giving us together with other kinds of things, does that actually do well in terms of predicting not only are they central, but also then we'll look at are they good information spreaders. So here's different categories that people could fall in. So let's look at a household. Suppose that I'm a household that nobody named when asked if I was a good diffuser, and I'm not a leader. Then I'm 90% of the population share, but the chance that I'm in the top 10% of the centrality is really low. If I'm not nominated but I'm a leader, so if you just looked at the leaders, you would pick more central people. Okay, so now we're doing a little better than just looking at somebody at random in the village. But I'm not doing that great. I'm doing a little less than 1 in 5 of finding somebody who's highly central. If they're nominated, if I asked people, instead of using leadership, they do better than just picking leadership at naming central people. So the people that they name are more central than your typical person with leadership status. So now we're up to about a little less than 25%. And then if you take people who are nominated and have leadership status, then you do really well. So at that point, you're up to about a 50-50 chance of each person that they're naming being in this category. And once you start correcting for the fact that now they're naming multiple times, if you look for people that are highly named, then you can get close to like 80 or 90% after they've been named 3 or 4 times. So it very rapidly, you would just have to ask a few people, and you would get highly central people putting that together with the leadership status. So just in terms of a picture, this is one of the villages now drawn with a different program. We can look at who the leaders are in this village, that are the shopkeepers, self-help group leaders, teachers, and then who was nominated. So actually you can begin to see, they're focusing in on a few households. Again, the nominees tend to be more central than the leaders. And then when you look at the ones that are both, in this case, I think you have 4 out of the top 7 most central nodes in the village. So you end up doing pretty well in terms of picking off who are the right nodes with a fairly simple methodology, right? So just asking people, we can get a lot of information about who's influential in the village. Okay, that doesn't necessarily mean that these people are good information spreaders. So next step, let's see if we actually use these people, would they spread information well? So what we did was we did a controlled experiment. And we partnered with a cell phone company that wanted to give out free cell phones and start getting the villages used to cell phones. And so what we did was we gave them, we seeded in each village. So now these are going to be different villages that we used for this experiment. We did 210 villages in total, 70 where we randomly picked some households, 70 where we picked sort of village leaders and village elders, and 70 where we picked people that we asked via these gossip questions that were nominated. And then what we did is we told them, look, we're going to be in the village in a few days. We're going to be giving out some free cell phones. If you come, you can roll a dice. If it comes up less than 12, we give you some money, which was somewhere between 25 and 275 rupees, which for them, again, at 50 rupees a day is a substantial amount of money. And then if you happen to get a 12, you get a cell phone. So that was and then we said, tell your friends. So this was information, and we told them there's no limit on how many cell phones we're going to give out. So, don't worry about congestion, tell people about it. And so this is what we happened in the random households. So when we went into the 70 villages, some villages we seeded 5 different nodes, some we seeded 3 times. The number of calls that we got back, or people that showed up for the cell phone giveaway, was somewhere between 0 and 20. So the max out was 19, I think, and we're here between 0 and 20, basically. Okay, if we use the elders, the sort of leaders, we do better. So there you end up, sometimes getting above 20, between 20 and 40. And then when you go to the gossips, the biggest one was over 100. Now you're really getting a much better diffusion, and they are indeed picking out more central people. So now we've been collecting data on the centrality of all these individuals. So hopefully soon we'll have an accurate measure of the centrality of all these, and we can tie the whole picture together. But they're doing much better if we use the names that they gave us to diffuse than the names of the people that just had some status or were randomly picked. And you can do statistical testing on this. The distributions are significantly different, and the denominated ones. It's not just your eyes; they're really doing much better. Okay, so on to our last question then. So now what we had the bank go in, they offered loans. We've seen information diffuse and so forth. Now we want to see whether or not the actual intervention by the bank had any impact on the social structures in the villages. And so we took advantage of the fact that they only entered roughly half the villages to go ahead and use that as a controlled or natural experiment to see whether or not those villages would look different afterwards than the villages that didn't have any exposure to microfinance. And so let me start by now, we'll come back to Al Capone and favor exchange, or Don Corleone. So we'll start with a model of favor exchange, and what we're going to do is talk a little bit about how this ties together with other relationships. So ultimately, we might be interested in the fact that people are getting information through the same networks that they might be borrowing and lending through. So maybe we were borrowing and lending money, and now the bank comes in, I don't need to borrow and lend money. That means possibly some of my links are going to be destroyed, but maybe it also means that now I don't talk to people and ask advice from them. Maybe I also don't exchange kerosene and rice with them, so those other relationships could also be affected. And now we're going to get into the multiplexing that was talked about earlier today. Okay, so I'll start with just sort of a simple economic model, but the idea here is that there's a complementarity between these behaviors. So let's suppose that we're in a borrowing and lending of kerosene and rice network. So somebody comes to me and asks me, they need to borrow kerosene, and I have to give up some kerosene to them. Now, it could be a long time before they repay me in terms of kerosene. It's possible that, it might be a month, maybe I'll never get it back. So this is costly to me. And generally what I'm going to do is I'm going to value, sort of what's the cost in a purely economic model of this sort of game theoretic model of reciprocity. I would be willing to give them the kerosene as long as the future expected value of that relationship is bigger than the cost. And so if I'm just doing these economic calculations to say, look, this friend's always asking me for kerosene, I never get anything back, forget it. But if I think that, I'll be getting something back in the future, then I'm part of the friendship. That's the basic idea. And so your cost has to be lower than the future value of the relationship. Okay, so where does support come in? So this is actually out of a paper I wrote with Tomas Rodriguez-Baraker and Shu Tan, when we started to look at local network structures and how they depended on the type of favors that were being exchanged. So let's think of now 3 villagers, and I'm asked to loan kerosene to George. I don't do that. If I don't do that, now instead of just losing the relationship with George, I'm also going to lose the relationship with Raisa. So I'm going to lose 2 relationships instead of just 1, because they're going to react and say, Matt doesn't lend me things when I want to. And so the power of having these relationships, having multiple relationships with different people, means that now we're able to support things that we weren't able to support before. So the idea is that the social ostracism and the network connections mean that now I face my reputation going bad and losing more relationships than just the one. Okay, so that's what we'll call support, and that's using multiple people to support a relationship. And the other thing we could think of is multiplexing. So an alternative way of doing this is, instead of us just, me going to one person for kerosene and another person for money and somebody else for advice, we'll start to layer these relationships on top of each other. And now when I'm asked for kerosene, I realize if I don't give the kerosene, maybe I'm not going to get advice from this person anymore, or I won't be able to borrow money from them. So these relationships now become layered on top of each other. And again, if we do this, now it could be that these 2 people have 2 different types of relationships, and the 2 different types of relationships now reinforce each other. And the fact that we're going to be interacting more frequently because we're doing more things together means that the value of the relationship's higher and expected value in the future, and now it's more costly for me not to perform the favor. So the idea is that either of these things could end up helping reinforce the presence of the first relationship and enables that kind of relationship. And that means that these things should layer on top of each other. Okay, so we should see things that are multiplexed. We should see things that are supported in the network. Okay, so we've got these two different ways that we might put things together: multiplex, supported, and obviously we can put them together in multiple ways. So just a couple of background points. If you look at the number of relationships in the villages that are multiplexed and or supported, it's about 90% of the relationships. So many of the relationships fall into one of these two categories. And in fact, if you look at that compared to the relationships that could be there that aren't there, it would be less than 10%. So there's it's not happening at random. It's not just that every link would naturally be multiplexed and supported if you just put it there. It's the fact that the ones that are there tend to be heavily multiplexed and supported. Okay, so the hypothesis now is, if we come in with microfinance, we're going to disrupt the borrowing and lending relationships, because now people have access to 10,000 rupees from a bank, and they don't necessarily have to borrow from their friends. So these relationships might disappear, and then links that are supported or multiplexed with money should also disappear at some rate. So the idea is that taking these out means that now it's going to be harder for us to sustain those other relationships that used to be aided by the fact that we were borrowing and lending money together. And a second part of the hypothesis might be that links that aren't supported, so if we're in a situation where they're not supported by money and or multiplexed, then those shouldn't disappear. So the idea is here, some might disappear, the ones that involve the money somewhere, and other links might not. So we can look at kerosene and rice, we can look at advice, we can look at other types of relationships and see whether they're affected by the pulling out of these money relationships. Okay, so those are the hypotheses. And in terms of the timeline, again, in 2006, we surveyed the villages. 2007 to 2010, the bank went into a subset of them, and luckily for us then didn't go into all of them. 2011 and 12, we resurveyed all the villages. And one question you might be worried about is maybe they went into some of the villages and not others in some systematic way that is going to bias this, and the villages might be different. I'll just do a picture, and then we have a lot of statistical analysis to show that the two village groups are the same on pretty much any dimension we can see. This is just geographically. I took out Bangalore so you don't know where Bangalore is, just for anonymity of the villages. And this is a deformed GPS thing. But you can see that the villages that they entered versus the ones they didn't in terms of a geographic map. Basically, it involved which loan officers happened to be in which areas, and that the rollout for us seems to be pretty orthogonal to features of the villages. Okay, so here, let's think of red dotted links as money links. These are people that used to borrow and lend money together. And now we can think of some other link, such as borrowing and lending kerosene or rice, and we could think that this is one that was multiplexed with money. This is one that was supported by a money relationship. This is one that's supported and multiplexed, and so forth. And the idea is we start pulling out these money links. These kinds of links, the blue ones, might start disappearing. This link here might disappear. This one might disappear. Some of these could disappear because they're no longer being supported by this. But the ones that involve no money, there's not an obvious effect that they should have. There might be a secondary effect. There might be a ripple effect through the network, but a first order effect, they shouldn't really be affected because the money relationships aren't pulling out. So we want to test, first of all, do these go away? And second of all, do these not go away? Okay? And what we're going to do is what's known as a diff and diff, difference in differences. And the way we're going to do this is now we've got the villages that they entered and the villages they didn't. So part of the problem is just over this time period, the nature of the networks could have changed. And so what we're going to have to do is a comparison between what's the rate of change in the villages that had the microfinance versus the ones that didn't. And we'll do the comparison between those changes, and that'll be the test, because otherwise it could be that just naturally the villages are changing in nature because the technologies are changing around them and they're becoming slightly wealthier and other things are happening at the same time. So we'll use the control villages to then serve as a control. Okay, so first of all, what happens, this is microfinance villages minus non-microfinance villages. And this looks at money links from the wave 1 and then money links from wave 2. And what we're doing then is seeing what's the survival rate of a money link in microfinance compared to non-microfinance. So here, this is negative, so they're disappearing. And they're disappearing. The money links are disappearing whether or not they're supported with money or whether they have some other kind of relationship. So if you look at just a money link, whether or not it's involved with other money links doesn't matter. Those tend to disappear. And that wasn't completely obvious because you could imagine that people that got loans now are going to have, do more lending than they used to, or you could imagine that it would go positive. But in fact, money links are disappearing from the villages that had microfinance relative to the villages that don't. They're surviving at a lower rate. And in fact, in terms of percentage, so this is a 5% drop. The links tend to survive at about a 35%. So it's about a 1 in 7, roughly 1 in 7 change here. So it's about 1/7 drop in the microfinance villages compared to the non. And given that only 20% of the households actually take up microfinance, then that's actually a large externality. Okay, so now let's go to kerosene and rice. And here what we can do is now say, okay, these are the ones that had somehow were multiplexed with money or supported with money. They're negative, again, about 5%. Then the ones that didn't involve money, they're not changing. So a good control, this is the second hypothesis, if money wasn't involved in supporting this kerosene or rice relationship, we shouldn't see it disappear. And if it is involving money somehow multiplexed, then we should see it disappear. So it disappears, and we see a significantly positive drop in those. Okay. Advice links, again, about a 5% drop. And here you actually see a slight increase. It's insignificant if it's without money, and then insignificant change if it was just a loan link. So in both cases, when we look at these other types of relationships, borrowing and lending kerosene and rice, going for advice, these are being affected by the disappearance of the money links. And they're being affected only when they're in contact with these money links or multiplexed in some way, and that's driving them down in the microfinance villages versus the other ones. Now, obviously, we're not going to say much. We don't know exactly what the welfare impacts of that are. So I'm not going to make welfare comparisons here because we don't know whether this is a good or bad thing for the villages. But what we do know is it's changing their network structure, and it appears to be changing it in a way where some of these links are disappearing as a result of the microfinance intervention. Okay, so this looked at survival. So one question you might have, maybe they're just rewiring. So maybe the money link disappears to somebody that got microfinance, and so I just form new relationships on the side somewhere else. And what you can do is you can go through the same exercise just on overall rates of survival of these things, not in seeing new ones are going to form and so forth. And in fact, what you do see is you do see some new ones forming, but you see the new ones forming, so the old ones are disappearing and the new ones are forming so they're disappearing at a higher rate in the microfinance villages, and they're forming at a slower rate than in the microfinance villages. So there is some replacement of these things, but much faster. They're growing at a faster rate in the non-microfinance villages. And again, the net rates are negative in all these cases when you look at the overall rates of these links. And you can do, so that's having an effect on the overall structure of these things. Okay, one other thing that's sort of interesting as a result of this, and I think you could have seen a little bit in some of the earlier talk, if you start pulling out links from a network, that's not only going to affect these relationships on a dyadic level, it's actually going to affect overall structure of the network. So the density is going down. And in fact, you can look at sort of how close are nodes to each other. So if you look at the average closeness in the network is significantly, if you look at the microfinance villages afterwards, you're getting a drop in closeness of about 0.02% here. So it's not a huge effect, but it is meaning that the villages are becoming slightly less connected than they were before in terms of information spread as well. Okay, so just in terms of summary on this changes part, relationships serve as complements in terms of the theory. Multiplexing and support are actually high in the data. We're seeing a significant difference in survival rate of links that are supported and multiplexed with money compared to in the microfinance versus non-microfinance villages. And we're seeing, basically money links falling, the distance increases in those networks, and the links supported and multiplexed with money fall So we're seeing that. And I guess the implication of this really, sort of the takeaway, is that exposure to formal institutions is going to change social network structure. And most importantly, it's going to change things not only in the directly affected relationships, but the fact that things are multiplexed means it's going to affect other relationships beyond the immediate ones. And so if we want to think about what the impact of microfinance is, it's not only changing borrowing and lending networks, it's also changing kerosene and rice networks, it's also changing advice networks. And we have to understand that better to really holistically design and understand the impact of programs. So we want to know how should we design these programs. We might want to understand now who's talking to whom and how that's changing as a result of this. So this is just sort of a first step in this direction. And in terms of broader messages overall, the message of this talk is obviously network structure has important economic consequences. We can measure these things using fairly simple techniques from network science and fairly simple tools of off-the-shelf, simple epidemiological models to define centrality, looking a little bit at the multiplexing to try and understand what incentives might change as some networks change. This other part, I think, is something else that we might think about more as social scientists in the future, is what do we really know about the community around us? So we do know a lot about the people immediately around us. How aware are we of the broader social structure in which we're embedded? Because that's going to be important for us to have good access to information, to have to know who's a zealot and who's not a zealot, and things like that. Those are things that somehow we come to know, but how do we come to know them, and how accurate are we? So I think that's another interesting question overall. So I think that's a good place to stop, and thank you very much for your attention.
Thank you, Matthew. Questions from the audience?
Yeah, so a question based on something I find sort of ironic about the story you told. Specifically with a cell phone company, right? So early days of cell phone, they come to you to try to figure out who they should go to diffuse cell phones within a village. Now, of course, cell phone companies are in the driver's seat. They know enormous amounts about social networks, about who calls whom, what their logs are. So I'm just curious, as sort of a big data question about this kind of work in developing countries, but maybe even a little bit more specifically, kind of how you think about cell phones in particular, both in terms of how they've affected social networks, and also kind of the cell phone data that is held mostly proprietary, but cell phone data that cell phone companies have on this really rich interaction, and what kind of opportunities that presents both for researchers to understand networks and also maybe for people designing programs the way you've kind of motivated your talk.
Yes, very good question. And I think when you look at modern technology, cell phones, email, social media in general, it's certainly changing the ways that people interact. And I don't think we fully understand the consequences of that. And part of the motivation of looking at this last piece is that could have a lot of consequences because our relationships are multi-layered. The information that's present, so one other thing to say is that I think even though the technology has made it a lot easier for us to be reached directly, but from companies and from all kinds of outside influences, word of mouth, if anything, becomes amplified in that kind of world. Now people can have more connections and can broadcast to more people. I can follow people on Twitter. And so actually human communication that's self-generated is becoming amplified by this, and people can reach more people at greater distances. They can connect to people who have similar ideas to them. All of these things are happening, and that's changing the social fabric in ways that we don't really understand. I think, obviously, people are data mining large data sets to try and figure out, can we see user patterns that are going to predict new adoption behavior, or who are good nodes for seeding this kind of stuff. So that's certainly going on, an important part of viral marketing. And I think that this fits into understanding that, obviously we're looking at part of the reason that we wanted to look at these villages is they're relatively isolated, and we have we can get a fairly complete look at them. Whereas if you go into what's going on in Davis, the connections are going outside of Davis in a big way. And so that makes it much harder as a scientist to study that. But I think, to some extent, it's not the humans that are changing as much as possibly the set of interactions, and we don't know enough about that to understand as scientists what the impact is, although marketers can get a lot more information about person's behavior and what they're interested in and what they're likely to do and how that depends on their neighbors. So it's a fascinating world to be part of.
So I just kind of had a question that was kind of related to the reflection aspect on a network, right? So you're friends with people who are like you. So we're kind of thinking about microfinance, and a lot of what we're worried about is kind of targeting. Is this getting to like the most poor, And so I guess I kind of wanted to probe that. You're thinking about centrality, and centrality might get the most information out there, but who's it getting out to? And I guess I wanted to, kind of investigate that.
Sure.
Just dimension.
So first of all, the microfinance does, the participation in the programs depends heavily on characteristics. And in fact, more educated, wealthier, larger families, older people tend to take up microfinance at higher rates. So all of those are significant predictors of microfinance. There is a lot of homophily, so those, they tend to be concentrated and they will know each other. With these size villages where there's only about 200 households, once you're seeding about 5 or 10 households, there's a good chance that you're hitting different modules or components of that network. And so that means that you don't have to worry so much about the cuts in the network. But if you were in a larger society, or if you could only seed 1 or 2, then exactly who you pick, you might really want to take into account the fact that there's a lot of homophily, and people tend to be associating with other people who have really similar characteristics, and that can distort the way that information is going to spread around the network. And it really does slow things down. So there's a lot of other studies that look at how that can slow diffusion, and those kinds of barriers are important. And I think ongoing study in peer effects.
Thanks for the talk, some very interesting results. I'm wondering, so here you're introducing these institutionalized lending, say, to the small villages. I'm wondering if you'd be able to use these results to sort of run backwards. Consider like the world economy or the state of California that already has these institutions, and it's some centralized institutions, and use these results to inform what would happen to the network structure if things were, say, decentralized, how it would affect the robustness or other things like that.
Yeah, I mean, I guess part of the reason for developing some of the models and looking at this is to try and do counterfactuals. So understand what would happen if you were in a different world and what the policy impacts would be. As a social scientist, you're always really cautious about drawing inferences. So part of the difficulty here is we don't even know what the consequences in terms of welfare are. So people are losing some of these links, maybe because they don't need them anymore. Is it causing more inequality among the households that have microfinance from not? We don't even know the answers to those questions. So I think at this point, it's sort of a first step in a longer process of really understanding what the implications of a lot of the interventions might be. And once we have models like that, then we can do more counterfactuals. And at this point, I'd be a little cautious to sort of draw conclusions on a large scale about what would happen if we if we made microloans. Microloans are coming to the U.S. as well as the developing world. Microcredit is much more available than it used to be. What are the consequences in the U.S. going to be? I would be a little hesitant to extrapolate at this point. But it certainly could have unintended consequences that we want to understand and take into account when we're designing those programs and figuring out what the ultimate impact will be.
So this is related to some of the remarks that you were just making about unintended consequences. There's a vision from the time of Gandhi that there's extraordinary richness and intelligence and capability in the villages of India. And Bunker Roy has sort of been pushing, with his Barefoot College, the sort of latent potential. So are you engaged in metrics of the kind of cultural change that's a consequence of specific loans? And on the flip side, given the climate of corruption in India and the environmental degradation, are you actually finding that people with resources are engaging in pro-social or self-aggrandizement?
Actually, one of the fascinating things about microfinance is that measurable impact of it has not been nearly as large as people would have expected. And I think one reason for that is, this is a conjecture, this is opinion, and it's that, when you ask people what do you use a loan for, because when they tell the bank they're supposed to be using it for some productive purpose, I'm going to buy a new seed, or I'm going to invest in a new silkworm frame. But in fact, a lot of times they are using it for an emergency, family emergency, a wedding, and they have to pay a dowry, all kinds of things where there's expenses that are coming up. And to a large extent, it's being used probably for income smoothing. And that means that it doesn't change their life so much in terms of, that now they're suddenly going to be investing and becoming entrepreneurs and handing out money, but instead they're not living near starvation for 6 months, where it used to be that they, once they planted their seeds, then they had to wait till the crop came in before they had any money again. And so they had these long periods of fairly rough months. And now they have a loan that can smooth that out. And so it's quite possible that part of the reason there could be a large welfare improvement, because now people can smooth out their expenditures and so forth that don't tend to do so well at savings. So that could be a quite positive thing without having a lot of these other external effects. And so there hasn't been a lot of effects. I think measurably, microfinance hasn't changed the world in the ways that we would expect directly.
One more question.
This one. So you found that with microfinance, I lose some link and I have some new link. But have you looked at whether I'm more likely to be have links with people similar to me overall or not? As you said, similarity has big impact, and maybe that will give us some idea about welfare.
Yeah, so some stuff I didn't present. We do know that people who take up microfinance are forming new links, and they tend to be forming them disproportionately to new microfinance. Other microfinance people, and people who are not involved in microfinance are actually losing links overall relative to the microfinance people. So there is a differential impact of this, and we're just working through all of the statistics on that, but it's pretty clear that there's a significant difference between those. And now whether the homophily is increasing, a guess would be yes, just because of that effect that we're seeing more among microfinance people who tend to be similar to begin with, but we don't have measures on that. And I'm not sure whether we'll have enough power, given the number of microfinance households to test that, but it's an interesting question overall.